So when you think of what is a chemical reaction, you might be thinking, well, that's something that involves an explosion or things mixing together to bubble and produce something exciting. But from now on, whenever you hear the term chemical reaction, I want you to think of a process that involves reactants transforming into products. So what does that mean? A reactant is something that reacts with something else. So most chemicals, all chemicals. And a product is just something that's formed as a result of that process. So basically, a chemical reaction then, very importantly, always forms something new. So new substance is always formed in the process. So if nothing new is formed, if there's no product, then it's not a chemical reaction. And there are ways that we can recognize that a chemical reaction has actually happened. There are signs of a chemical reaction that we can look out for. So what might they be? You could have a color change. You could have a solid being formed, and I'll come back to that one. You could have a gas being given off, or the temperature could change. Now there's a couple of them that can be confusing, so we're going to have to go over this. Very importantly, these changes don't include things like melting or freezing or evaporating. Anything that's just a change in state doesn't tell you that a chemical reaction has happened, necessarily. So, for example, if I have some water and that's liquid water, I put it in a cup and then I put that cup in the freezer. Come back a couple hours later, I take the cup out of the freezer and it's went from being a liquid to a solid. Now that is a change. Something has happened, right? The state has changed from liquid to solid, but the chemical that I put into the freezer was water. The chemical that I got out of the freezer was water. It's not changed chemically, it's just changed physically. So these 4 changes here are chemical changes specifically. They're not physical changes. Okay, so if you mix 2 chemicals together, or 2 or more chemicals together, and it changes colour, that's a chemical change. If you, for example, mixed 2 liquids together, and as a result of that mixture, something solid was formed, right? You didn't change the temperature or put it in a freezer or anything like that. It just did it as a result of the reactants reacting together, then that's a sign of a chemical reaction. If a gas is given off during a reaction, that's a sign. And if the temperature changes, but you didn't change the temperature, it wasn't externally done, right? You didn't put it in an oven or a freezer or anything like that. You mixed 2 chemicals together and the temperature started to change as a result of that mixing, then that temperature change is a sign of a chemical reaction. So basically, did these things happen as a result of you adding things together? Then that tells you it's a sign of a chemical reaction. Okay, so something new being formed, and those are the ways in which we can tell that it's happening. Now on top of that, there are a couple of types of temperature changes that you should be aware of. And these types of reactions that have temperature changes have specific names. So we call these exothermic and endothermic reactions. So what does that mean? Well, an exothermic, which sounds a little bit like explosion, which might be a way you can remember this, is a reaction that will release heat energy, and as a result of releasing that energy to the surroundings, to the environment, it will get hotter. Okay? Now again, very important distinction to point out here. You are not putting it in an oven or externally heating it. Just from the chemicals reacting together, right, just from coming into contact with one another, because of the chemistry that's going on there, the whole mixture is getting hotter by itself almost, right? Which lets you know that it's a chemical reaction and it's not a heat change that you are making to it. It's doing it itself. It's getting hotter. And if it gets hotter, that means energy is being released. And if energy is being released, it's an exothermic reaction. Now the opposite can happen as well. So what if it's an endothermic reaction? Well, in those, It's just the exact reverse. The reaction is absorbing heat from the surroundings, it's taking it in, and as a result of that, the mixture will get colder, or the reaction will get colder. Okay? So the two different types then, exothermic, which gets hotter because it's releasing energy to the environment, which we feel as heat, and endothermic is taking that heat in, away from the environment, it's sucking it in, so the reaction vessel gets colder. And a simple way to remember this, because that can be quite confusing, is that in an endothermic, the energy is entering the reaction, so remember the En, and in an exothermic, the heat energy being released is exiting the reaction. It's just a case of remembering which one gets hotter and which one gets colder.